Welcome to clickmyproject.com. Our product title is High Throughput Pipeline 2D Discrete Cosine Transform for Video Compression. Now we are going to discuss about our product abstract. In our process we have done the transmission video streams since the video has very challenging qualities. Using the DCT, Discrete Cosine Transformer, express the sequence of the finite many data points in terms of the some cosine functions. Mostly the DCT they have considerable amount of the carried the proposing the algorithm, the implementation them the general purpose computers of the DSP, digital signal processing. I have created the discrete 2D approaches result and Foster's algorithm. The Foster algorithms with the minimum number of the multiplications of often realized and the flexibility of software approaches. The speed of the DCT in the video conversation and the image to be processing the input blocks the host computer such the Pentium processor, the DCTQ processor, whereas the discrete cosine transformation is performed the followed by the quantization. And then DCT processing can be viewed the block box of the input and output, define the shoot of the application's requirements based on the energy detailed specification of the formulate the DCTQ design will expand. After the modifying the architecture of the process, the parallel signed order and the simple algorithm has been proposed. The DCTQ applications the speed the proposing the topmost priority. The signed orations can be realized with the 7 2 inputs adders, 5 pipeline stages. In the first stage of fourth number of the 12 bits to complement adders are used to order the all 8 numbers. They work concurrently, thereby speeding by the processor. After we go into the high level system architecture using the DCT, the processor implementation in the FPGA implementation of the input data and insert the system of the every 8-bit the sequence. Actually many DCT designs insert the input DCT of the parallel the DCT computing the video conversion the sequence and manner of the 8 blocks cycle insert the data. Now we are going to discuss about our product flow diagram. In our process we have first ECG get the signal from data set and to filter the input ECG signals using the MATLAB 2013 software and to apply the low pass filters and to pass the MATLAB into silings. So first we couldn't get the file directly for silings, so we are going to the MATLAB coding how we create the signals and to text the convert the text. So we are using the MATLAB 2013 and then we go into the DFT based QRS detection feature extraction architecture. And then many we are using the signal processor, so we use filter the some noise. So we are using the Gaussian kernel unit, the approximate multiplier, the structure of the process, and going to the cardiac based P elements architectures. The processing elements we some give the input signals and the based on the what we create the threshold value for the EC signals or normal and abnormal persons values. So we create the some processing element architectures and then we go into the scaling unit functions level. This process we get the data set support vector processing, all pre-processing work in the support vector machines and to set the method of the threshold values as yes and no conditions and match and mismatch conditions, so normal or abnormal persons in the level. So using these scaling factors using the silings process, finally the matching the result overall ECG database set samples we get the lot of ECG signals and from method for get normal and abnormal is we conduct the arrhythmia, tachycardia, bradycardia. So some variation of disease we calculate and to display the LCD displays and then waveform displays. So finally we get the last waveform from using the how we disease the head get the values, how percentage of the values, so creating the flow of the process. Now we are going to discuss about our product running procedure. This is our main code of the source code. We are going to implement that video compression using the MATLAB 2013 and Xilinx 14.2 version software tool. And we going to the running the process for the MATLAB main code. So first we select this path, the directory of the coding path, and go into the paste here, simulate the process. So using the MATLAB, the video compression. This is the main coding for this. So this is how we get the coding for video frames. We convert to the text to the read the input file, the Xilinx code. So first just running the process. So data sets, we have the data sets for the 3 videos. So whatever we get it, the first video we get it. So compression processors have applied the DCT, and then the architecture of the 12-bit adder and some 8x8 multiplier. So these processes, the architecture based designed in the Xilinx code. The automatically open the Xilinx process in our process. Just I'm going to run the process using the Xilinx. So simulate the process, just the main code of the click, and then simulate the behavioral model. So automatically open the iSim modulator. We give the some input for the clock and enable the some bits. After we get the running the process the completed. After going to the enter the some numbers in the MATLAB. After you open the compressed video, the clip opened. Just first I give the input parameters for the clock. First of all I give the enable the process, input the values. So all give the values for zeros and ones the process. Just we give the input, the run the process. So after we go into the MATLAB process, enter the some numbers. So enter the number of values. So automatically second frames read the process. So that same level we go into that every frames. We have connected the 10 frames level for the each and every frames for compressed. After connecting, lastly we connected to the 10 frame, up to 10 frames we click on that the compressed video, open the process. So after the compressed videos, the level of the properties we give the level is compressed the values. So same level for we give the inputs for the clock and reset enable. So all of the things I have enabled the start automatically in that in the codings we enabled. So we will get the MATLAB process. So enter the next number. We provide give the in level. After we go into the enter the value. So enter. So you get the clip, the second moment of the values. So then provide the values continuously as we compress the videos. So thank you for watching the video.